Dear students, welcome to today's class. So last few classes I have explained what is inverse trigonometric functions and properties of inverse trigonometric functions and the various formulas I have given. Okay now. So based on this, now we are going to solve a few problems which were given in previous JEE mains examination. See here, in JEE mains examination, sometimes you will get questions directly from inverse trigonometric functions, but sometimes there are some problems which were mixed with calculus or trigonometry, calculus or algebra, something or geometry, like that mixed type of problems are given. Because one type of question is here. Limit n tends to infinity, tan of sigma r runs from 1 to n tan inverse of 1 upon 1 plus r square is equal to. It is a problem mixed both trigonometry and calculus. So if you simplify this, applying limit n tends to infinity and getting the answer is not at all a difficult task. First you simplify this. Now I will come in a systematic way. The first thing is tan inverse of 1 upon 1 plus r square. Okay, now tan inverse of 1 upon 1 plus r square. First I will simplify this. Afterwards I will apply sigma. Afterwards I will find out tan of. Next afterwards I will find out limit n tends to infinity. So one by one systematically I will come. So first one is tan inverse of 1 upon 1 plus r square. Okay, now how to split it? How to split? Let us see here, this can be written as tan inverse of 1 upon 1 plus, this is 1 plus r. Can I write it as r plus r square? Can I take r common outside? Yes, I can take the common outside. Right. In the numerator, tan inverse of, can I write it as 1 plus r minus r by 1 plus r into r plus 1 into, 1 plus r into r. Can I write it as, right, I can write. Why? Plus r minus r will get cancelled, 1 upon as it is. Now if you see this, this is of the formula tan inverse of a minus b upon 1 plus ab. As I has already given the list of formulas, tan inverse of a minus b upon 1 plus a into b is given as tan inverse of a minus tan inverse of b. Okay, so actually there is no by hearting of this problem. Tan of a minus b is equal to tan a minus tan b by 1 plus tan a into tan b. If you remember that main basic formula, this is very easy one. Okay, now here it is becomes tan inverse of 1 plus r minus tan inverse of r. Tan inverse of 1 plus r minus tan inverse of r. Okay, now so up to this part is over. Now I am going to apply the sigma notation. That means sigma r runs from 1 to n. Tan inverse of 1 upon 1 plus r square means what? This is the concept. That is equal to tan inverse of 1 plus r minus tan inverse of r. Okay, now r runs from 1 to 2. So first you apply r is equal to 1, 2, 3, 4 like that, and you can if there is definitely surely you will get some cancellation terms. Okay, so ultimate what is the ultimate what remains, let us continue the solution. So this is equal to, first r is equal to 1, you substitute, this is equal to tan inverse of 2 minus tan inverse of 1, first bracket, plus tan inverse of, in place of r, already 1 is over, no 2. That means tan inverse of 3 minus tan inverse of 2 plus so on. Last term is tan inverse of n plus 1 minus tan inverse of n. This will be the last term. Now what are the terms to be cancelled? So clearly, so if you observe here, tan inverse of 2 and minus tan inverse of 2 will be get cancelled. If goes next it will come tan inverse of 4 minus tan inverse of 3. Like that, this tan inverse of 3 also will get cancelled. Ultimately, what are the things remains means that should be taken careful means. Observe this. So, how to what the things it will come now, generally students will get confused here. In these two brackets, first term is cancelled with the last term. First term is cancelled with first term of the first bracket is cancelled with the second term of the second bracket. Like this. For example, here one term will be there. No, here one term will be there. This first term and this is a last term, second term of the second bracket. These two will be get cancelled. Okay na? Okay na? Like that, this also will get cancelled. If we want to cancel this, there should be one bracket here, but that is not there. If we want to cancel this, there should be another bracket should be here after that. That is also there, not there. So therefore, ultimately, what are the things that remains? Tan inverse of here n plus 1 minus tan inverse of 1. Those are the two things that remains in the bracket. Okay na? Right. Up to here completed. Up to here it is completed. Now tan of, apply the tan of. So that is equal to tan of tan inverse of n plus 1 minus tan inverse of 1. Okay na? Right. Before that what is there? Before that what is there? Limit n tends to infinity is there. Limit n tends to infinity. Limit n tends to infinity means what here? N plus 1. As n tends to infinity, n plus 1 is also tends to infinity. So, sorry, here tan is there. So, therefore, it here tan inverse of infinity is equal to how much? So, this is tan inverse of infinity. Tan inverse of undefined means what? How much? Pi by 2 minus tan inverse of 1 is pi by 4. Pi by 4. So, this is equal to tan of pi by 2 minus pi by 4. That means 90 minus 45. That is 45. Tan pi by 4 is equal to how much? 1. Tan pi by 4 is equal to how much? 1. Understand this? Okay. So, very systematically we solved this problem. So, we started with from here. Next I applied sigma, next to tan, next to n tends to infinity. As I already told you, limit n tends to infinity, the calculus part is a very, very minute here. The calculus role is very, very minute here. The only thing is inverse trigonometric functions and trigonometric functions. Okay. I hope that you understand these questions. Let us go for next problem. Welcome to second problem. Very, very easy problem. Cosecant of 2 cot inverse of 5 plus cos inverse of 4 upon 5 is equal to. Very, very the first thing what the happy thing that we feel is the question is very clear. There are some problems it is very difficult to understand the question also, what is given data, what we have to prove, but the problem is very clear. So here first thing is cosecant of. So our target is to express this in terms of cosecant inverse something. If you express cosecant of cosecant inverse, then what is the value, what out will come, whatever may be the value will come, that will come here. So that is your answer. Okay na? Now cosecant, sorry. So this is. Then how to express the given quantities which were present in that bracket into cosecant inverse. So let us move systematically one by one. First thing, let us call it as theta. You call it as theta. So therefore, cot inverse of 5 is equal to theta. This implies cot theta is equal to 5. Cot theta is equal to 5. So this is equal to 2 theta. 2 theta. This is equal to 2 theta. Apply tan 2 theta, that is equal to 2 tan theta by 1 minus tan square theta is equal to 2 into this is 1 by 5 upon 1 minus 25. Understand this? So this is equal to 10 by, so this is 5 will get cancelled, 5 will go to in the numerator, that is 10. 25 minus 124. So, this is equal to 24 means this is 5 by 12. So, that means 2 cot inverse of 5. 2 cot inverse of 5 is nothing but, so I have find out tan 2 theta. So, tan 2 theta. So, this is equal to 2 cot inverse of 5 is equal to, so we can write it as some alpha. If you take this as an alpha, therefore that means 2 alpha, this is a 2 theta, otherwise 2 theta is equal to tan inverse of 5 by 12. This is 2 theta, that means in place of 2 theta, you can write down tan inverse of 5 by 12. That see here cos inverse of 4 by 5, that is very clear. Cos inverse of 4 by 5 means this is 4, this is 5, this is 3, 3 by 4, 3, 4, 5, adjacent side upon opposite side. Ultimately, your problem will become cosecant of, this is tan inverse of 5 upon 12 plus, this is we can call it as this also you express into tan inverse. Tan inverse of how much? This is tan inverse of 3 by 4. Tan inverse of 3 by 4. Okay now? Very nice. So, both the things I expressed in tan inverse. This also tan inverse, this also tan inverse. Again, this is equal to cosecant of, this is equal to tan inverse of A plus tan inverse of B. Tan inverse of A, that means 5 by 12 plus 3 by 4 upon 1 minus 5 by 12 into 3 by 4. Tan inverse of A plus tan inverse of B is equal to tan inverse of A plus B upon 1 minus AB. So, this value is cosecant of tan inverse of. This value if you calculate, this is a 56 by 33. 56 by 33. So, please calculate these values. I already calculated. So, without wasting our valuable time. So, you please calculate this, right. Up to here cosecant tan inverse we got. Then what we are doing to is now tan inverse. Let us take the right angle triangle and we will write it in the cosecant. Up to here we got. So, here cosecant is this also you will express into cosecant inverse. So, let us take the right angle triangle. So, this is equal to opposite side is 56, hypotenuse is 33. Apply the formula, so that is equal to AC square, you call it as ACB. AC square is equal to AB square plus BC square. So, definitely you will get 65. Okay, calculate that, you will get 65. So, this is equal to cosecant of, cosecant inverse of, tell me what is the definition of cosecant inverse? Hypotenuse by opposite side. Hypotenuse by, if you take theta, hypotenuse by, that is 65 by opposite side 56. Cosecant of cosecant inverse is equal to 65 by 56. So, this is out of 1, more than 1, that means here minus infinity to minus 1 union 1 to infinity. So, this is out of 1 to, it lies between 1 to infinity, therefore, you can take the value 65 upon 56. Ultimate your answer is 65 upon 56 is your answer. Dear students, what I did, the very easy thing is, this value and this value I have expressed into both into same inverse trigonometric function. Preferably tan inverse of, this also tan inverse of. Again, I put it in the tan inverse of mode and I will continue the problem. Okay. I hope that you understand this solution. Let us go for next problem. So, welcome back to next problem. Here the problem is, if sin inverse of x upon a is equal to cos inverse of x upon b is equal to tan inverse of y upon c, where x value lies between 0 to 1, then the value of cos of pi c upon a plus b is. So, this is a mixing of both trigonometric ratios and inverse trigonometric functions, as I already told you. So, we cannot get exclusively problems from inverse trigonometric functions, they will get a mixed problems. Okay. So, let us see here Let us first take whenever such type of things are given, we will call it as is equal to lambda. Let us take that. Therefore, sin inverse of x is equal to cos inverse of x by b is equal to lambda. From that I will write down directly. So, sin inverse of x is equal to a lambda, cos inverse of x is equal to b lambda. Next, tan inverse of y is equal to c lambda. So, this is a lambda, b lambda, c lambda. Okay now. So, from this can we get any relations? Any relation? Yes. I have one formula. What is that? Sin inverse of x plus cos inverse of x is equal to pi by 2. Already have given a formula. Sin inverse of x plus cos inverse of x is equal to pi by 2, where x belongs to closure bracket minus 1 to 1, where x belongs to closure bracket minus 1 to 1. Okay, right. So, here sin inverse of x plus, that means a lambda plus b lambda is equal to pi by 2. A lambda plus b lambda is equal to pi by 2. From this, lambda is equal to pi by 2 times a plus b. Very nice. Lambda is equal to pi by 2 times a plus b. So, here a lambda plus b lambda is equal to pi by 2. So, lambda is equal to pi times pi upon 2 times a plus b. Coming to here, so coming to here, tan inverse of y is equal to c into lambda value is how much? 2 times a plus b. Pi by 2 times a plus b. So, tan inverse of y is equal to pi c by, so what is your tan inverse of y value? Pi c by 2 times a plus b. Put it like that, call it as 1. Now, coming to your problem. What is your problem? Cos of pi c upon a plus b. This is equal to cos of pi c upon a plus b. Pi c or c pi upon a plus b. Pi c upon a plus b is equal to 2 times tan inverse of y. Pi c upon a plus b. Pi c upon a plus b is equal to take cross multiply. Now, cos of 2 tan inverse of y. Whatever may be in the inside, how to express in the cos inverse. Cos of cos inverse get cancelled, you will get answer outside. Okay. So, let us continue the solution. You can write directly the answer. If you have the grip over the formulas, you can write down directly formula. Cos 2 tan inverse of y is equal to 1 minus y square by 1 plus y square. Immediately you can write down. The list of formulas we have given. Okay, now, right. How to do this, sir? You just remember cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta formula. It is there or not? Cos 2 theta, you call it as theta. Let theta is equal to tan inverse of y. This implies tan y is equal to theta. Okay, now, so this is equal to cos 2 theta is equal to 1 minus tan square theta. 1 minus tan square, here 1 cos 2 theta is equal to, so here theta is equal to tan inverse of y. Therefore, tan y is equal to theta. Therefore, so this is equal to how much? 1 minus y square by 1 plus y square. Let us see here. Let theta is equal to tan inverse of y. Therefore, cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Okay, now. So, this is equal to 1 minus tan square theta by 1 plus tan square theta means how much? So, this is equal to 1 minus tan theta is equal to how much? So, here tan theta, this is equal to tan theta is equal to y. Theta is equal to tan inverse of y, therefore, tan theta is equal to y. So, 1 minus y square by 1 plus y square. So, ultimately answer. Okay. Just if you look at the problem, cos 2 theta. Cos 2 theta in terms of tan, 1 minus tan square theta by 1 plus tan square theta. So, your answer is option A is your right answer. Okay, now I hope that you understand this solution. Let us go for next problem. Welcome to the next problem. Very nice problem. So if 0 less than a comma b less than 1 and tan inverse of a plus tan inverse of b is equal to pi by 4, then is asked to find out a plus b minus of a square plus b square by 2 plus a cube plus b cube by 3 minus a power 4 plus b by 4 upon 4 whole so on infinity. Okay. So just to keep this expression, just to keep it like that. So first given data is what? So this is a tan inverse of a plus tan inverse of b is equal to pi by 4. Remember that tan inverse of a plus tan inverse of b is pi by 4, it is given. So according to the formula, tan inverse of this is a plus b upon 1 minus ab is equal to pi by 4. Tan inverse of a plus tan inverse of b is equal to tan inverse of a plus b upon 1 minus ab. Formula is there. So this implies a plus b upon 1 minus ab is equal to, if tan inverse applying tan on both sides, so tan pi by 4 is equal to 1. Okay now? Right. So this upon a plus b is equal to cross multiplication 1 minus ab. So take this side plus ab is equal to 1. Okay. So you take this minus 1 plus is equal to 1. Right. Adding 1 on both sides. Why? Because to make into factors. If you want to make it into factors, definitely 1 should be here. That's why add 1 on both sides, that is equal to 1 plus a plus ab is equal to 2. So these are the factors, 1 plus a, 1 plus b is equal to 2. So ultimately, if it is tan inverse of a plus tan inverse of b is equal to pi by 4, what we got? 1 plus a into 1 plus b is equal to 2. So in our course of time, so whenever 1 plus a into 1 plus b is came, in place of that we can substitute 2. Okay now. Now coming to our problem, let us see what we have to find out. We have to find out the value of this. Now what I will do now, I will put all a terms in one bracket, all b terms in other bracket. So I will putting all a terms, that means a plus a square by 2 plus a cube by 3 plus, so here plus minus plus minus. So here a, of course, sorry, here minus is there, minus a square by 2 plus a square by 3 minus a power 4 by 4 plus so on infinity. Here plus b into plus b, this is a minus b square by 2 plus b square by 3 minus b power 4 by 4 plus minus minus so on. Okay now, like that. So here what is this value? What is this value? You have to remember this. This is the expansion of log of a plus 1. That's all. So log of a plus 1 expansion is this plus, so this is the log of b plus 1 expansion. So this is log of a plus 1, log of x plus 1 is equal to x minus x square by 2 plus x cube by 3 minus x power 4 by so on. That you have to remember. No way. So this is implies log a plus log b, log of a plus b, a plus log of a into b. So this already we found out, a plus b into b plus 1 is values 2. Therefore log 2 is our answer. Okay. Nothing is here, nothing is here. From this easily we can get a plus 1 into b plus 1 from this. From this separating the a terms and b terms. So if we have a grip over the logarithmic expansion, so this is a clearly the expansion of log of a plus 1. This is clearly the expansion of log of b plus 1. Log a plus log b, log of ab. So we got the answer. Okay. So I hope that you understand this solution. Let us go for next problem. Let us welcome to the fifth problem. It was given tan inverse of y is equal to tan inverse of x plus tan inverse of 2x upon 1 minus x square, where modulus of x is less than 1 upon root 3. Then the value of y is, it was asked in 2015 mains examination. But the thing here, observe here, this is a very easy problem. Why? Because tan inverse of y is equal to tan inverse of x plus tan inverse of 2x. That means you can combine these two. These two, tan inverse of a plus tan inverse of b is equal to tan inverse of a plus b upon 1 minus a into b. And y is equal to tan inverse, both sides you can cancel and you can get y is equal to any one of the answer you will get. But the thing is, without the calculation part is somewhat lengthy, it will be there. Without doing that, can we make use of this data? Can we make use of that data? Let us use that. Okay. So here it is given that modulus of x is less than 1 upon root 3. That means what is that? Means 1 by root 3 less than x less than 1 upon root 3. Okay, now, so apply tan if you apply tan of minus 1 by root 3 means tan 30. That means tan pi by 6 less than tan x less than pi by 6. Tan 30, we can write this. So tan x lies between minus pi by 6 to plus pi by 6. Okay, now what we are going to do is, here tan x, let x is equal to tan theta. Let x is equal to tan theta. So here what remains? Tan inverse of tan theta. Right hand side I am taking. So tan inverse of tan theta is, that means tan inverse of y. We can take it as a tan inverse of y. Tan inverse of tan theta plus tan inverse of 2 tan theta upon 1 minus tan square theta. So tan inverse of tan theta is theta plus this is equal to tan 2 theta, this is equal to 2 theta, this is 3 theta. Okay, this is 3 theta. Okay, so now if you observe here, so here what we got? Tan inverse of y is equal to 3 theta, y is equal to tan 3 theta. Y is equal to tan 3 theta. What is y is equal to tan 3 theta? Tan 3 theta formula 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, that is equal to 3 into, what is tan theta value? X. Tan theta value is x minus x cube by 1 minus 3x square. Option A is right answer. So in a simple way I did here. Here modulus of x is less than 1 by 3. That means x lies between minus 1 by root 3 to plus 1 by root 3. That means your theta value, that means the angle lies between minus pi by 6 to pi by 6. Okay, now let us take x is equal to tan theta. X is equal to tan theta I have taken. Therefore, tan inverse of y is equal to tan inverse of tan theta, tan inverse of tan 2 theta. So theta plus 2 theta, 3 theta. So tan inverse of y is equal to 3 theta. Therefore, y is equal to tan 3 theta. Tan 3 theta means 3 tan theta minus tan cube theta by, so like that 3x minus x cube by 1 minus 3x square. I hope that you understand. Very, very easy problem. Otherwise, if you are not getting any this type of idea, just you take this problem. So this is equal to tan inverse of x plus 2x by 1 minus x square upon 1 minus x into 2x by 1 minus x square. You simplify this, you can get the answer. Like that also you can get easily. Okay, now I hope that you understand this solution. So dear students, I hope that you enjoyed today's class with some more topics and with some more new concepts. I will come before you. Until then, all the best.